Example 1, 2.6 is basically solving equations with roots. I've got that over there. If you're looking for a title for your notes, so you can always look over there for that, for the daily learning intention.
It's supposed to be up here.
Yep, it should be. Hang on here. There we go. All right, so example 1 is going to be to take this equation and solve for b. Yes, that's a b. Okay, so solve that thing for b. They could also ask you to solve it for a. Does it look familiar to anybody?
Yeah, it looks like
Pythagorean theorem, right? It is Pythagorean theorem. So if I want to get the b by itself here, what should I do? Square both sides. So for the sake of your notes, we'll be thorough and write that thing again. So I'm going to square both sides. Okay, so if I want to square both sides, I am going to have a c squared here. And then over here, the square and the square root cancel out, and I'm left with a squared plus b squared. All right? And remember, I'm trying to get b by itself. So what will be my next step to getting b by itself? Okay, subtract an a squared from both sides. So I have c squared minus a squared equals b squared. And now that b is almost by itself, it just has a second power on it. How do I undo a second power? Okay, square root both sides. So for the sake of your notes, I'll write it again to be thorough. So square root both sides, and then I get the b by itself. So what is b equal to? Nope, it's a square root of c squared minus a squared, and you simply leave it like that. You cannot take this and just make that a c minus a. Okay? And if you want me to prove it to you, here would be the proof of that. Keep in mind, remember that 3 squared plus 4 squared is equal to 5 squared? Okay? So in this case, that would mean 5. If I square rooted both sides, that would look like this. Right? If I square rooted both sides? Okay? So if you're thinking that the answer to this should be c minus a, if that were true, then the answer to this would be 3 plus 4. Right? Can I take the squares and the square root off of this? Is 3 plus 4 equal to 5? It's not. Okay? So that's why that doesn't work. Clearly, when you put real numbers in, that doesn't work. Okay? All right, so this is your answer right here, just like this. And why did I not put a plus or minus in front of it? Because I'm doing Pythagorean theorem, and Pythagorean theorem represents distances, right? Okay, distances can never be negative, so I don't have to worry about that. Okay? So no plus or minus is required here. All right, next one. Example 2. So this one is ME, this is a physics formula. That stands for mechanical energy, I believe. Is 1/2 mv squared plus mgh. And this time we want to solve for v. Solve for v. So if I want to get the v by itself, what do I need to do? It's already have a multiply by 2, right? Okay, that's a good idea. Get rid of your fractions by multiplying by a 2. So if I take every term times a 2, I'm going to have 2 times mechanical energy. And that's not 2 separate variables. Those are tied together. That represents one thing. So 2me is equal to mv squared plus 2mgh. Because if I multiply this one by 2, the 2 and the 1/2 cancel. So everybody good with that step? Stop me. This one had a 1 in front of it, so if you multiply that by 2, 1 times 2 is 2. Okay? This one had a 1/2 in front of it, so when you take 2 times a half, you get 1. This one had nothing in front of it, just a 1, so 1 times 2 is 2. Every term multiplied by a 2. Okay, remember I'm trying to get this by itself, so I need to isolate that term. How can I get that term by itself? I wouldn't divide by m yet. I would subtract this term.
So it's
right?
not altogether like the MGH. Is it one term?
This is a term, this is a term, and this is a term. Remember in math, multiplication and division glue things together, okay? Addition and subtraction are points of separation. So there's no glue here. So that's a point of separation. I have nothing but multiplication here. So to get this v, this term by itself, I need to take this term and subtract it to undo the addition, right? So if I subtract a 2mgh from both sides, I will get 2me minus 2mgh equals mv squared. Does that make sense? All right. And now I'm trying to get the v by itself, so now you can divide by that m. Okay, so if I divide everything by that lowercase m, for the sake of your notes, let me rewrite this to be thorough. 2me minus 2mgh is equal to mv squared, and I'm going to divide everything by m. And I'm just going to write it like this. If you want to write them individually and put each one over m, that's acceptable also. However, it will cancel on the second term, but not the first. Okay? So, this cancels, and so my answer is v squared equals 2me minus 2mgh all over lowercase m. Or another acceptable variation would be 2me over lowercase m minus 2gh. Because if you write them separately, the m's would cancel here. Does that make sense? And I don't care which way you write it. They don't care which way you write it. I typically leave it like this. Okay? Just because why do another step if I don't have to, right? Okay? Now I'm not done yet. I'm still trying to get v by itself, and this is what v squared is equal to. So what do I do to get v by itself? Square root both sides. So if I were to square root both sides, v comes out to be, and that's, I'm going to erase this for just a second. V comes out to be 2 capital M-E minus 2 mgh all over lowercase m, and that square root is over the whole thing. So you got to make sure you type the square root in first. You do the square root first, then put the fraction inside of it, then do your numerator and your denominator. If you do the fraction first, it's not going to put the square root around the entire thing. So I probably should have dipped this down low right here. Does that make sense? Okay? Crazy looking answer, but that's your answer. Okay? Everybody okay with that? All right. Example 3.
We should put a plus or minus on that one.
Oh, that's a good point. Thank you so much. So she says, would you put a plus or minus on that one? Well, what do you think V stands for in this problem? Anybody know? Velocity. It's a physics formula, so it's velocity. Can velocity be positive or negative?
Yeah.
It absolutely can. So you are right. You must have the plus or minus in front of there. So write yourself a note, must have, or don't forget, or something.
So on example 1, you don't need it.
Correct, because on example 1, you're doing Pythagorean theorem, and that's a distance, and a distance will never be negative, but a velocity can be negative. Okay? Everybody good with that? Somebody's going to come to me when they're certified on this, and they're going to want to know why they got it wrong. And I'm going to say you forgot the plus or minus. Just like I just forgot it, because it's an easy thing to forget, right? So make sure you put that plus or minus in there. Okay? And I believe the symbol is in the keypad for the plus or minus. Okay? All right. Example 3. This time we have a cube root of 7y squared plus 16y is equal to the cube root of 4y squared plus 12. Okay, so What do you think I should do to solve this equation? I'm trying to solve it for y. Okay, why would I cube everything? And they make this one, I mean, the problem would essentially be the exact same problem without the cube roots, right? It's just an equation that's got a cube root on both sides. When they have the same root on both sides with no other terms, it makes it a lot easier than, you know, if it was a cube root on one side and no root on the other side. All right, so if I cube both of those, it's going to look like this. And if I take a cube and a cube root, they cancel each other out. Okay, well now I got a quadratic equation, right? How am I going to solve that quadratic equation? Combine like terms. So if I combine like terms, I'm going to have what? 3y squared plus 16y and minus 12 equals 0. Well, how do I solve one of those? I factor using what type of factoring?
Or you could pull 3 out.
Nope, 16 is not divisible by 3.
So you'd box it, would you?
Okay, how about a box? Okay, now if the box doesn't work, you're going to have to use quadratic formula. How can you check real quick? Multiply these together. What's 3 times 12?
36.
Is there anything that multiplies to give you 36 and adds to give you 16? A negative 30. So there is, so we know a box works. So 3y squared, negative 12. We said if you multiply these two together, you get a negative 36. So we are looking for something that will multiply to give us a negative 36 and add to give us a 16. Irish said that would be an 18 and a negative 2. Is she right? 18 and negative 2? So 18 and negative 2. All right, well, what do those two top boxes have in common? A y. What times y will give you 3y squared? What times y will give you negative 2y? And what times 3y will give me negative or positive 18? 6. Okay, so this thing will factor down to 3y minus 2 and y plus 6. Okay, so if you solve on this one, you will get y equals what? And negative 6. Okay, y equals 2/3 and y equals negative 6. Okay, everybody okay with that? All right, now on a lot of these problems, they will suggest that you check your answers. On this particular problem, you shouldn't, I mean, if both sides are cube rooted in the beginning, the problem's really no different than this as far as the answers go, right? So if I take 2/3 and I plug it back into this side and this side, I should get the same thing. If you cube root the same thing, you're going to get the same answer, right? And anytime you do a cube root, can you get a negative number? You can't.
Yes.
Cube root, you can get negative number. Now, if this was a square root, we might have a problem here. Because if this is an even numbered root and this thing comes out negative, I can't square root a negative number, right? So you're really okay not to check your answers on these. If it's hard for you to know when you should and when you shouldn't, then just always check it, right, Corbin? Okay? So check cube root answers. If there's a cube root on both sides, you don't have to worry about it, okay? Or an odd numbered root. Like I said, if you want to just always check them, you can plug it in here, the 2/3 and the negative 6. You could plug it into both sides. Make sure that they're numbers you can cube root. Obviously, if you cube root the same number, it's going to give you the same thing, okay? The next one's an even numbered root, and we'll see where we have to check. Everybody okay with that? All right, so example 4. This time we have a fourth root of 6x squared plus 7x is equal to a fourth root for 4x squared plus 15. And actually, I'm going to change this up just a bit. I'm going to put a minus sign here and an equal 0 here. Okay, so what should I do first? I mean, clearly I'm going to need to take something to the fourth power, but you don't want to do that at this point. Yeah, let's move this over here so I have a fourth root equal to a fourth root. Then it makes it easy for me to just take both sides to the fourth power. When you don't want to take this crazy thing to the fourth power with a parentheses around it, because that means some crazy stuff. Right? If you take 2 plus x to the fourth power, that's not just 2 to the fourth and x to the fourth, right? That's 2 minus x times 2 minus x times 2 minus x times 2 minus x. And that's not fun when you've got something that crazy. So let's get our roots isolated to both sides. 6x squared plus 7x is equal to the fourth root of 4x squared plus 15. Okay, so what should I do to get rid of the fourth roots? Okay, take it to the fourth power. So fourth power and fourth root cancel each other out, and I'm left with 6x squared plus 7x is equal to 4x squared plus 15. Everybody with me? Okay, so we're solving a quadratic. What should I do? Like terms. So take 4x squared, subtract it from both sides. I get a 2x squared plus a 7x and minus a 15 equals 0. So I'm going to be looking for something that multiplies to give me negative 30. Multiplies to give me negative 30, adds to give me 7. Is there something that will do that? 10 and negative 3. Yep, that would work. So let's make our box. We'll put our 2x squared here, our negative 15 here, and you said the two things that would multiply to give me negative 30 and add to give me 7 would be a 10x and a negative 7x. Everybody good with that? Rihanna, does that make sense?
Would it be a negative 3?
Oh, right, yep, thank you. Is that what you were going to say, Rihanna? Nope.
No, like, why did you multiply the 2x with the 15 to get 30?
Because that helps me figure these two things out in the box. Okay? So if you can't find something that multiplies to give you this and adds to give you this, then a box isn't going to work. You're going to have to go to quadratic formula. Okay? Now, you don't have to do that until you get to the box. A lot of people just start their box. They put the 2 here, the negative 15 here, and then they multiply these two together to get these so that they can figure these out. I was just kind of doing that early so that I could see if a box for sure worked or not. Does that kind of make sense?
Yeah.
Okay? So if you don't do it then, that's fine. You can do it, over here when you're doing your box. Okay, so let's see. Factor out what they have in common. I get a what? X, a 2x, a negative 3, and a 5. Does that make sense? So I get x plus 5 times 2x minus 3 equals 0. So that means x is a negative 5 and x is a 3/2. But when you look back at this one, we need to be careful because if we plug negative 5 or 3/2 in here or in here and I get a negative, that's going to be a problem, right? Because I cannot take a even numbered root of a negative number, okay, without having i's, and this is not a complex number problem, okay? So we need to go back and plug those in. So this is a great time to use your graphing calculator app. So I would go to your app, and I would type in 6 times -5 squared plus 7 times -5, and I would see what I get. And then I would type in this one. I would type in 4 times x, which is a -5 squared plus 15, and I would see what I get. Okay, so on your graphing calculator app, type those two in and see if you get the same number and see if you get a positive number. And do you see what I'm doing there? Do you see where I got those? This came from here, and this one right here came from this. Now, a lot of people would go ahead and fourth root that, but you guys, if you get if you get a positive number, you can take a fourth root of it. You get a negative number, you can't. Okay? So it's really all about, does it come out positive or negative for this problem? So, what do you get when you plug those numbers in?
115.
115, both times? Positive 115 on both of them? Okay, so we're good. Checks. Okay. Since we have a positive number. Now, I can always take a fourth root of a positive number. Does that make sense? Okay, if this would have come out a -115, what would I have done? No solution. At least, well, I take that back. We've only checked one of the answers, right? You need to check them both because maybe one works and the other one doesn't. So we still need to check the 3/2, right? So let's do that again with a 3/2. So this time I want to type in 6 3/2, or you can do a 1.5 squared plus 7 times 3/2. Then 4 times 3/2 squared plus 15. And they should come out the same number. I'm really just worried about whether they're positive or negative. So if you type those in your calculator, what will you get?
24.
24? Positive?
Yep.
Okay, so they give you a positive 24. So that's great. We can do a fourth root of a positive number. Okay? So I have two answers. These two both work. Both work. Okay? Everybody okay with that? All right, we are ready for example what, 5? Example 5, let's say we have something like this. Cube root of 6x minus 8 equals 4. Now in this section, you want to always check these, whether it's an even root or an odd root, because anytime you have a root on one side, you always want to check your answer. Yes?
Okay, just a quick question.
Yep.
The last one.
Yep.
If they were both negative,
No solution.
no solution.
Yep. If those both would have come out negative, you'd had no solution. Okay? All right, so on this problem, so anytime you see a problem and there's a root on one side, always check your answer. Okay? When there's a root on both sides, you really only need to worry about it if it's an even numbered root. But when you just have a root on one side, just rule of thumb, always plug it back in and see if it works. Okay? All right, so this particular problem, how would I solve it? Cube both sides, right? Cube both sides to get rid of the cube root. Okay, cube and a cube root cancel each other out. I'm left with just a 6x minus 8 on this side. How about 4 to the third power? That's 4 times 4 times 4, 64. Okay, well that's an easy enough equation to solve. Add an 8, right? So 64 plus 8 is 72. 72 divided by 6 is 12. So x equals 12, providing it checks. Okay? So if I go back and check it, cube root of 6 times 12 minus 8. Does it come out to be 4? And you can just type it in the calculator. It'll be 7264. Yep, should work.
Yeah.
Okay, everybody good with that? So checks. So we're good. X equal 12 is our only answer. Everybody okay with that? All right. How about this one? 4th root 3y minus 10 equals negative 2. Okay, how am I gonna work this out?
Is this example 6?
This is example 6. Everything to the 4th power, right? Both sides to the 4th power. And what do I get? Do we know what negative 2 to the 4th power is? Negative 2 times negative 2, 16, right. So now we want to
Give me a second.
add 10. If I add 10 to 16, I get 26. And y equals 26 thirds. Okay, so now let's check that in our original problem. That was a 4th root. Anybody know how to type a 4th root in the calculator?
You do the little,
Yeah, you can use math 3, is that right? Math 5, or you can also do this. You can do quantity to the 1/4 power. That's another way to do a 4th root. Okay? But you can use math 5 also. So let's see, my quantity was the 4th root of 3 times 26 thirds minus 10. What do you get if you take a 4th root? Do you get negative 2? What happens?
It's positive too.
Ah, it's positive 2. Okay, so when I plug this in my whole calculator, I get a positive 2. I don't get a negative 2, I get a positive 2. So this is a perfect example of where when you plug it in, and think about that. When you take a 4th root, that's an even numbered root. Are you ever going to get a negative out of that? See, I really could have stopped you at the beginning, and if you notice that, hey, an even numbered root can never come out negative, and just said no solution right off the bat. Okay? That would have been fine as well, but I wanted to send you through it, check it, and show you that you don't always get the same thing. Okay, so this one is no solution because my original answer was negative 2. Okay?
Does that always happen with the negative?
If you have a negative and an even numbered root, yes. Okay, is everybody okay with that? All right, example 7. This time, let's say we have the square root of negative 6x minus 5 equals x. Now, once again, this is definitely one you're going to want to check. You've got a variable on one side, you've got a root on one side, so we'll definitely be checking this one. Okay, what should I do? Square both sides to get rid of the root. Get rid of a square root, you need a square. Okay, so if I square a square root, I end up with negative 6x minus 5 equals x squared. Now what? Okay, move everything over. I always try and keep the x squared positive. So plus 6x plus 5. Yep. Okay, what multiplies to give me 5, but adds to give me 6? 1 and 5. Okay, so x will equal negative 1, and x will equal negative 5. So remember what the original problem did not have these green squares on them, right? So I'm going to plug negative 1 and negative 5 back into both sides, and I want to see if I end up with the same answer. So I want to know, does the square root of negative 6 times negative 1, I'm just going back to the original, right here, replacing the x with a negative 1, does that equal x, which is a negative 1? So I replaced this x and this x with a negative 1, and I want to see, does this actually come out to be a negative 1? Well, what do you think? Is a square root ever going to give you a negative number? So do you even need to work that out? No. Okay? So that one's not going to work. Is the other one going to work? The other one is,
Why would the other one work?
yeah, it's not going to. It's a negative also, right? Is a even numbered root ever going to come out negative? No. So, nope, not going to happen. No solution. Does that make sense? Okay, and you can type them in the calculator. I mean, if you type this in the calculator, you're going to get 6 minus 5, which is 1, and then the square root of 1 will just be 1, not negative 1. There's no plus or minus in front of those things. Now, if there was a plus or minus in front of that thing to include the negative 1, then you could be okay, but there's not. Okay? They were the ones that gave you the square root, so the owner of the problem has to put the plus or the minus in front of there. If this original problem had a negative sign out here, you'd be okay. Okay? But it doesn't. All right, everybody okay with that example? Okay, we're ready for 8, is that right? Okay, so example 8. Let's say we have the square root of 3y plus 25 plus a 7 that's not underneath the square root equals y plus 6. Okay, what next? What would I do here? I wouldn't square everything yet because of you have 2 terms on this side, yeah. Let's put the 7 over here so I have just the root on this side. So that'll be what, y minus 1? Everybody good with that? So now, since this one's a little more complicated, we'll be a little more thorough here and write it twice for your notes, because I am going to square both sides. Okay, is everybody with me?
Why would that square, like,
I have to square both sides. Okay, so on this one, when I square both sides, the square and the square root cancel out. And I'm just left with the 3y plus 25. And that's the easy side. When I square this side, remember that's now, and I'll see this mistake clear through the test. People are going to just take that 2 and distribute it to these 2. They're going to call that y squared minus 1 squared, and that's not the case. How do you take a binomial, meaning 2 terms, and square it?
Square the first.
It's like a box, right? Okay, that's the shortcut. So it's like y minus 1 times y minus 1. So you can do that a multitude of ways, okay? There's a shortcut, and I'll use the shortcut a lot. But in Algebra 1, you learned it like this, right? Or you used a box, and you did it like this. And you figured out what went inside the box. There is a shortcut to that, and I call it square the first, square the last, multiply, and double. Okay, did you guys learn that in Algebra 2? Maybe not, I'm not sure. It's not a big deal if you didn't. You may have done it always this way, okay? But I want you to think about, if I were to do a box with this, negative y, and positive 1. Notice that this one is just the first one squared. This one is just the last one squared. And if you put these 2 together, it would give you negative 2y. Well, that negative 2y can be obtained by simply multiplying these 2 terms together. Y times negative 1, which is what I get here, and then doubling it. Right? So rather than writing this box out every time, I just say square the first, square the last, that gives you these 2. And then to get this middle one right here, you multiply these 2 together, y times negative 1, and you double that because it happens twice. So square the first, square the last, multiply, and double for the middle term. So if I square the first one, I get y squared. If I square the last one, negative 1 times negative 1, I get 1. And then I multiply these 2 together. just like I did here, y times negative 1, y times negative 1, that's negative y, and then I double that. So negative 2y. Square the first, square the last, multiply and double. Catchy little phrase. You'll learn it quickly because you'll do it 100 times. Okay, not necessarily in this lesson, but over the course of several chapters you will. Is everybody okay with how I got that? Okay, and you can always go back and do it this way. It just takes a little longer. Okay, right, Catherine? All right, so now I have a quadratic. How can I solve that quadratic? Get everything on one side, right? So subtract 3 from both sides, and I get a negative 5y. Subtract 25, and I get a negative 24. Okay, so now I have a 1, so that means I can skip the box. Is there anything that will multiply to give me negative 24 and add to give me negative 5? Okay, where do I need the negative?
Negative 8.
Negative 8? Okay, so y minus 8 and y plus 3. Is everybody good with that?
Yeah.
Multiplies to give me negative 24, adds to give me negative 5. Okay, so now I have two answers for y. Y is an 8, y is a negative 3. Don't forget, anytime you got a radical on one side, you've got to check your answer. So we're going to go back to the original problem and put 8 in for every y we see, and also negative 3. So in your notes, you might even put, don't forget to check something, so that when you're looking back at your notes, you won't forget to check. Okay, so original problem, replacing y with an 8. So 3 times 8 plus 25, then plus a 7 outside. Does that equal 8 plus 6? So there's where I put the 8s, right there. So in other words, I want to work this out and see if I get 14. If I do, it's an answer. So that's 24 plus 25, which is 49. So I end up with the square root of 49 plus 7. Does that equal 14? I believe it does. 7 plus 7 does equal 14. We're good. So y equals 8 is for sure an answer. Yes, it works. It checked. Okay, let's check the negative 3. That would be 3 times negative 3 plus 25 underneath the square root. Make sure if you're typing that in the calculator that you close your parentheses there. And then plus 7. Does that equal negative 3 plus 6? Okay, so let's see. That's going to be, what, negative 9 plus 25. What's 25 minus 9? 16, I believe. 25 minus 10 is 15, so minus 9 would be 9. So 25 minus 9 is 16. So I have that. Negative 3 plus 6 is 3. So that's 4 plus 7. Does that equal 3? No. So that one does not work. So I have to go back and throw out the negative 3. So y equals 8 is an answer. Y equals negative 3 is not. What if they both did not work? No solution. And that's possible. That can happen. All right, is everybody okay with that? Because that's our last example.